Yeah, your voice is audible. No, no, you can attend anyone. Yeah, so the time might clash, but yeah, I mean, it's up to you. Whoever's teaching you prefer, you can attend that lecture, because those timings are based on our availability, and it is possible that two sessions are clashing. But it is basically for you to choose. It's an option for you to which session or which instructor suits you the best. You can attend that lecture. Yeah, yeah, you have 3 TAs. Yeah. Okay, so I will wait for maybe 2 more minutes and then we'll start. Okay. Okay, so I think it's 6 7 minutes past 3, so I think we can start discussing uh, today's topics. Okay, so just let me check if everything is working fine, so that there are no hiccups. So fine. So hello, namaste, and welcome everyone. I am Piyush. I am a research scholar at Indian Institute of Science, Bangalore, and uh, so uh, so this is a probability and statistics offered via NEPTEL by IIT KGP, and so these TA sessions are going to be basically means to solve your problems and basically verify, basically solve your doubts and have some problem solving sessions, and maybe solve some assignment questions which might be helpful for you if you are going to credit this course and eventually give exams. So we will be using Teams for meeting. Maybe let me just share my screen. All these lectures are going to be recorded, and these are going to be recorded using OBS Studio. So I prefer OBS as compared to Teams, because OBS is sort of an offline thing. Even if I get disconnected somehow or there is some internet hiccup, I will still be able to record the entire lecture as it is through OBS, as it is offline. So there is no reliance on internet for this recording, so I will be using that. So just let me do this thing, and okay, I will be now, let me share my screen through share screen. I will be using my tab to basically broadcast my whatever lecture notes or whatever I am writing. And in case you are not able to see what I am writing, just let me know, so that I am aware of what is being broadcasted and what is not. Alright, so maybe you can get started. Okay, so this is tutorial 1. Okay, this tutorial is going to be sort of an introductory session. So basics, and this today is going to be just a session on basics, right? So okay, everything is fine, just checking. Okay, screen is also visible, so no issues. Okay, so okay, so some logistics. These tutorials, so what are going to be timings? Timings are going to be 3 p.m. to 5 p.m. on Saturdays. Okay, these might occasionally change. These might occasionally change because I might be having some other commitments, some PhD related coursework related things at my end. So if that is the case, these timings might change occasionally, and if it changes, you will be informed via email by the NEPTEL team. Okay. Second thing is so what are we going to do in these lectures? So okay, maybe I will just write what to expect. So first of all, these are TA sessions. Okay, so these are TA. sessions. Okay, these are not your actual lectures, so I won't be covering everything. So this won't be like a replay of the lectures that are already uploaded on NPTEL portal. These are going to be these are more going to be problem oriented. What do I mean by that? I mean that these will be focus will be on problem solving, doubt clearing, what else? In case if there is some request from your side, it might also include revisiting some concepts. Okay, so this is what it is going to be. Okay, when I'm saying problem solving, what does it mean? Won't be solving current assignment problems. Okay, just a second. So as if you are taking this course, you might be aware that you have to give a weekly you have to basically solve some weekly assignments, and so in these TA sessions we won't be solving those questions, because those problems are supposed to be solved by you and you alone, right? Those are not supposed to be solved by us, otherwise that will be like some sort of cheating. However, we will be solving similar problems, right? So it might not be your usual assignment questions, but the problems that we will be solving will be similar in nature, and more particularly these will be past year questions. These will be past year problems. So for example, if you are right now maybe solving week 1 problems, in the TA session we will be solving week 1 problems of past years, not this year. So hopefully that should kind of give you an idea of how to solve this year's problem. Sometimes there might be some overlap between these problems, but yeah, I mean rarely, but yeah, it's possible that there's a overlap between these problems. But if that is the case, I don't really mind. Like 1 or 2 problems is fine, but the entire lecture won't be about those. The entire session won't be about the same set of problems. So that just want to make that clear. So these are the things that you can expect from these from my TA sessions. Okay, right? So maybe we will just get started. Yeah, if there is any question, you can just unmute yourself and ask it. If there is no question, I'll assume that everything is fine and I'll just keep moving forward. But I highly encourage you to sort of, yeah, just if you feel to ask some question, you can just ask question. Don't hesitate, or don't be sort of intimidated. What will I think, or what will others think? Yeah. So right now I can see only one participant, and yeah, I mean from my experience of NPTEL, usually this number, the number of participants is usually 1, 2, or at max 5. but this was the first lecture, so I was assuming a bit of more participation, but if that is not the case, not an issue. We will just move forward with what we thought, what I had planned. All right, so maybe we'll just get started with some problems from last year. Some questions might overlap, but yeah, all of them won't be the same. There will be differences. Okay. Okay. Okay, we'll get started. So maybe on some other page. So let's start. So first problem that we are going to solve. I think this problem is there in this assignment as well, but yeah, anyways, I will just solve it nonetheless. What is this question asking? So in case my screen is not visible, or my voice is breaking, or any shenanigan you face, please just inform me. I will just immediately do something about it. Okay, feel free to interrupt me. So here is the first problem. I think this is there in this times problem sheet as well, but yeah, let me solve it nonetheless. It's a simple question. So let's say you have two words. One is probability, and the other word is statistics, right? And so you are basically going to choose a random letter from this word and a random letter from this word, right? So let's call this this random variable as, let's say, x. So whatever the random letter that you choose, I'm denoting that by x, and if whatever the random word you choose from here, let me call it y. Maybe let me use capitals to just emphasize that. So this is x, this is y, right? And the question is, what is the probability that x is equal to y? So it's a fairly straightforward question. So it's a basic elementary probability. So first of all, what are the common letters that can occur together? There is a, right? A is there in both probability and statistics. What are others? There is I is there in probability as well as statistics. What else? There is T, right? T is also here. Is O there? No. L, no. Y, no. Not P, not S. I think these three, right? So yeah, so I think these are the only common words that can occur together. Someone is trying to join. Yeah, I admit it. So if that is the case, then so we have to just see what is, so this probability, this is going to be what? This is going to be probability that x equal to a and y equal to a. That is one possibility when both the letters can be the same. Plus probability that x is equal to I, comma y is equal to I. Okay. Plus probability that x equal to t, comma y equal to t. So this probability is going to be the desired probability that we want. So what is the probability that x is equal to a and y is equal to a? So now we will be using something. So So these are this event is basically intersection of two sets, right? So so when I am writing x is equal to a, y is equal to a, what do I mean? What I mean is the set of omega that belongs to omega such that a such that x of omega is equal to a intersection omega that belongs to omega such that y of omega is equal to a, right? So like strictly speaking, this is what I mean when I write x is equal to and y is equal to a. And if you look at it, these two events are actually independent because we are independently choosing the words from each of the we are independently choosing letters from each of the words. So if the events are independent, probability will just become the probability of intersection is just the product of probabilities. So this is equal to probability omega belonging to omega that x of omega is equal to a into probability omega in omega such that y of omega is equal to a, right? And this is equal to probability that x is equal to a, and just in short terms probability y is equal to a. So just just being a bit pedantic, if I am using, so probability need not be written like this here, I can just write the probability measure p, right? Not a big issue, but yeah, nonetheless just being careful here, right? So this is what it is. And so what is the probability of x being a? So there is only one occurrence of a, right? Okay, and how many total letters are there? 1 2 3 4 5 6 7 8 9 10 11, right? So the probability of this term, so this event is 1 by 11 into what is the probability of y being equal to a? There is one a here in statistics, and how many total letters are there? 1 2 3 4 5 6 7 8 9 10, 10 of them, right? So this is 1 by 10. Okay, maybe just resize it to just make sure that this is not equal to the above thing. Right, so I'll just keep it here. Yeah, just coming back, so this is equal to basically 1 by 110 plus. Similarly, we can calculate the probability of I, x equal to I, y equal to I. How many i's are here? 1 2 2 i's, right? So this is going to be 2 by 11 into how many I in statistics? 1 2 of them, so 2 by 10, right? Plus coming to t, there is only one t here in probability, so it is going to be 1 by 11 into how many t in statistics? 1 2 no, okay, there are 3 t's, so 3 by 10. This probability is going to be 3 by 10. So it will become 1 plus 4 plus 3, right, over 110. So 4 plus 3 7 plus 1 8 by 110, this is equal to 4 by 55, 8 by 110, which is equal to 4 by 55, right? So I think this is the answer, right? So yeah, in case, so this was a very simple question. If you have any question, you can just interrupt me and ask questions. Okay, please don't hesitate. We are all here for learning new things. Okay, and just let me make sure that my recording is going fine, because if that is not okay, things are not going to be fine for me. Okay, Seems like it's going okay. Okay, so that was your first question. Let's go to the next question. Again a simple question. So let's say there is a 10-digit phone number, 10-digit phone number, right? And so there is a person, he remembers the first 7 digits properly. So let's say that, okay, so it's a common situation. So there's the person, this person here remembers first 7 digits. So he doesn't, okay, someone is again trying to join. Okay, so he doesn't remember last 3 digits. Okay, so the question is that, and what is the probability of dialing the correct number? Probability of dialing the correct number. This is the probability that you are asked to calculate, and there is one assumption that you have to take, that all these digits were 0, 1 till 9. These are equally, the probability to choose each of them is equal. Okay, so there is a uniform distribution over all these 3 digits. So basically what is the case? There is a 10-digit number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The person remembers first 7 digits, 3, 4, 5, 6, 7. He doesn't remember the last 3 digits. And now what he is going to do is he is going to randomly choose 1 digit here, 1 digit here, 1 digit here. And the question that we are asked is, what is the probability that, what is the probability that he gets the number correctly? Okay, so I think you will agree that if he has to correctly dial the correct number the only thing that he needs to do is he needs to pick these 3 digits he needs to pick these 3 digits correctly, right? So, and these 3 digits are fixed, the correct digits are already fixed. So what is the probability that he chooses exactly those digits? So this is simple. Let's call this, just copy this thing, just copy it, paste it. This is going to be, so let's assume that let's say that without any loss of generality, the correct digits were, let's say, A, B and C. Okay, and each of these events is going, so each of these outcomes can be represented using some random variable. Let's call these the random variable for this place to be X, this place to be Y, and this place to be Z. So what is this probability of dialing the correct number is eventually going to be probability that X is equal to A, right? This random variable should have this outcome, Y should have this outcome, Z should have this outcome, right? See people joining. Okay, so if that is the case, this probability is going to be probability of X is equal to A, Y is equal to B, and Z is equal to C. This probability can again, now since each of these are going to be so each of these picks are going to be independent of each others, that much we can assume. So the entire probability can again be written through independence to be probability of X is equal to A into probability of Y equal to B and probability of Z equal to C, right? So again, just to recap, we have 10 digits. The person remembers the first 7 digits, he doesn't remember the last 3 digits. The question that we are asked is, given this condition, given this situation, what is the probability that the person dials the correct number? And we said that let's say that the correct numbers were A, B and C for the last 3 places, for the last 3 digits. And since the person is going to randomly pick a digit from here, we are calling that random variable as x, the random variable for this place to be y, and random variable for this place to be z. So we concluded that the probability of dialing the correct number is going to be the probability that x is equal to a, y is equal to b and z is equal to c. In fact, the probability is going to be intersection of these 3 events. So we want all of these 3 events to happen simultaneously. We don't want them to happen we don't want y to be b and x to be something else, right, or z to be something. We want x, y, z to be equal to a, b and c respectively at once, simultaneously. Then since the person is going to choose each of these digits independently, we can just write the product of, so probability of intersection as product of the individual probabilities. Now things are simple. So basically the question is, you are going to pick a random digit from 0 to 9. What is the probability that that particular digit is equal to a? That is the question. Well, that is a simple thing. I think since each of the outcomes is equally likely, we can say that the first term will be equal to 1 by 10, right? Similarly, the second term is going to be 1 by 10, third term is going to be 1 by 10, and hence this probability is going to be 1 by 1000 or 10 raised to minus 3. Okay, so this is the, so in case there is any question or any doubt, please let me know. Otherwise I'll move to the next problem that I have. And so this was the second question that we solved today. So yeah, you can just feel free to just ask questions by unmuting yourself. So it is possible that I am looking at the screen and looking at the questions on my screen, and I'm not looking at I'm not looking at your Teams I'm not looking at the meeting currently. So it is possible that if you write something in chat, I won't be able to see it, and hence I'll miss it out. So it's better to just unmute yourself and ask questions. So let us look at another question. Okay, so this is another question. So let's say there is a set A and it contains only 2 elements, 0 and 1. Okay. Okay, so the question that is, so you are given 3 options. Okay, so let me write all the 3 options. The first option, so the question is which of the following is a sigma algebra? Question. The first option is phi 0. Okay, the first option is phi 0 and a. So remember, a is the entire set. Okay. The second option is phi 1 and a. The third option is phi 0 1 and a, and the last option is 0 and 1. So the question is, which of these is a sigma algebra? So if you remember, sigma algebra has to satisfy two properties. Well, it has to satisfy actually 3 properties. The first property is that phi should belong to the sigma algebra. Okay, I will just so okay, so let me call, okay, I will just maybe call this as M. So if M is the sigma algebra, phi has to belong to that sigma algebra, right? The second property is that if A belongs to the sigma algebra, that implies that A complement should belong to that sigma algebra. And the third property is that if uh, if A1, A2 and so on belong to the sigma algebra, this implies that the countable union over I, AI should belong to the sigma algebra, right? These three properties has to be satisfied in order to call a collection sigma algebra. So let us go over each of these options one by one. Quite simple to see actually. Maybe I'll just keep them here. So in this question, in the first option, you can see that, so if phi belongs to the sigma algebra, its complement should also belong to the sigma algebra, right? So this means that if phi, so this means what is the complement of phi? Phi complement is the entire set, right? So it's A. So this should also belong to the sigma algebra, right? So in this, so the options that don't contain phi and A can straightforward be ruled out, right? So this D option that you see here, it doesn't contain phi or phi and A. So this option we can straightforward say that, okay, this is a wrong option, right? This is not going to be correct. All other options contain phi and A, so we need to check them individually. Now here you see that 0 belongs to M, this collection, let's call it M1, okay. So but for that to be a sigma algebra, 0 complement, which is equal to, so it contains only two elements, right, 0 and 1. So if the complement of 0 is going to be just this set with element 1, this should also belong to M1, but that is not the case, right? So again, like, since 1 doesn't belong to this is also not a sigma algebra. Let us look at the second option. Here again, 1 belongs to this, let's call this M2. So this, if for this to be a sigma algebra, 1 complement, which is equal to 0, should belong to M2, but that is again not the case, and this is also not a sigma algebra. C option, okay, in the C option you see that, okay, phi does so let's call this M3, phi belongs to M3, A belongs to M3, okay. So the basic sets are there. 0 belongs to M3, right? So this implies that 0 complement, which is equal to 1, the set with just the element 1, should belong to M3, and that is the case. We do have 1 here. And there is another condition, remember, countable union. So if 0 is there and 1 is also there in M3, this implies that union, so this implies that 0 union 1 should also belong to M3. But what is this? 0 union 1 is actually nothing but this set 0 comma 1, which should belong to M3, and this set is nothing but your entire set A, right? This thing. So A should belong to M3, and actually A is already there in M3, so you need not do anything, right? So all these sets that we want there to be in this sigma algebra is there, and hence the C option is the correct option, and hence this is a sigma algebra. So Adarsh, can you I just saw your chat, that is why I was saying that I cannot look at the chat when I am actually writing here. Can you was this clear to you, or was it not clear to you? Can you just tell me so that I can explain it to you again? So you asked me to, Okay, clear. Yeah, Adarsh, maybe you can also just type it out. Okay, this one is clear. Fine. Thanks. Yeah, I would urge you to, just unmute yourself in case you have any questions, because while I'm writing, I really can't see the chat that you are posting here. I just want to know the previous question. Okay, so the previous question, this one, the second one. Uh, the previous question was a simple thing. So there is a person who has to dial a 10-digit phone number, right? And he remembers just the first 7 digits of this number, okay? But the last 3 digits he has forgotten, he doesn't know. So what he is going to do is he is going to randomly pick digits from between 0 to 9 and just try his luck out. The question is, what is the probability that he actually dials the correct number? Okay. So what we did there was, let's say the correct numbers were A, B and C. So there are 3 positions. We say that, let's say the correct digits that he should dial is A, B, C. However, and we are denoting x to be the random variable that will be put here. The outcome of this selection, is denoted by y, and outcome of this selection is denoted by z, right? So the probability of dialing the correct number is going to be the probability that x is equal to a, y is equal to b and z is equal to c. Otherwise, if that is not the case, then the numbers are not correct. And so we just don't so this probability of these event, we want them to happen simultaneously, meaning that we want x to be a, y to be b and z to be c at the same time. We don't want y to be b and x to be something else, right? So we want, in some sense, we want the intersection of these 3 events. And however, since these events are independent of each other, because the person is going to choose these numbers independently, the probability of intersection will be product of the individual probabilities, and the probability of each of them is going to be 1 by 10, because it is similar to asking the question that you are going to pick one number between 0 to 9. What is the probability that it is equal to a could be anything, a could be 0 or 1 or something like that. So the probability of that is like, you have one favorable outcome out of 10 possible outcomes, so this is going to be 1 by 10. Same with all 3 of them. So this is going to be just a product of these. So this will be 1 by 10 into 10 into 10, which is 1 by 1000, which is 10 raised to minus 3. This is the question and sort of a brief explanation of how we solved it. Is that fine? Okay. Okay, so moving on to the next question. So here is again a basic counting question, basic question involving counting. Okay, here's the 5th question. The question is that so there is a pack of 52 cards. Okay, so I hope you know what a pack of cards is. It contains 52 cards, right? There are 13 cards belonging to each of the categories, right? And the question that you are asked is, what is the probability? Okay, so you are going to pick two cards randomly, right? So there are 52 cards. You are going to pick any 2 cards randomly out of these 52 cards, right? So the question is, what is the probability that both cards being kings? So I hope that you are familiar with the notion of cards, right? so a pack of card, it contains 52 cards. It is divided into 4 subgroups. I don't remember all of them, but what is it? Diamond, I think it's one is diamond, right? Another is a club, one is heart, if I remember correctly, and there is one more, I don't remember. Diamonds, club, heart, spade, right? What is, or I don't even remember the sign of logo of spade. Whatever, I mean, there's something called spade also. Okay, so so each of them, so each card belongs to one of them, right? And the cards that are there are numbered from 1 to 10, 11, 12. Okay, 11, 12, 13. Yeah, okay, fine. I mean, there are so each card is actually divided into these one of these 4 groups. Okay, so the card can be either diamond, either club, either heart, or either spade. And other than that, they can be actually number cards. So they can be number cards, or they can be face cards. So face cards include what? It includes king, queen, and jack, right? And there is an ace as well. I don't know, ace is considered in a face card or not. So there are these 4 cards, and then there are 9 numbered cards from 1 to 9. Okay, the question that we are asked is, if you are randomly selecting 2 cards out of these 52 cards, what is the probability that both of them are kings? Okay, so from basic elementary probability, we know that this is going to be the number of, so there can be okay, maybe I will write it in terms of probability rather than hand waving it. So this is going to be what? So let's say that the random variable denoting the outcome of the first card is x, and the random variable denoting the outcome of the second pick is going to be y. Okay, so basically the probability, so this probability is going to be probability, so this is going to be the event where number of events where x is equal to king and y is equal to king, okay, upon all possible number of all possible outcomes, right? So there are 2 cards that we are going to select out of these 52, and we are going to select both of them at once. It's not that I choose first the first card first, and then I choose look at it and then choose the second card. That is not going to happen. We are simply going to select 2 cards out of these 52 cards. Okay, so this probability that both of them are going to be kings is simply the number of outcomes where both of them are kings divided by the total number of outcomes, right? So how many outcomes are there which will actually ensure that both of the picks are actually kings? So there are four of them, right? There are 4 categories of cards. Each category contains 1 king, right? So there are total 4 kings. If I want both my cards to be kings, I need to select 2 cards. So I need to select 2 kings out of these 4 kings, right? So there is so basically what I am trying to say is, there is maybe I will just write it somewhere here. So there is king of spade, there is king of club, there is king of heart, and there is king of diamond. Okay, there are these 4 kings. Any two of them would work for me, right? Any two of them will work for me. So what are the number of possible picks where I can actually choose 2 of them? So if you remember, there is something called, if you have seen combinatorics, it's 4c2, right? There are 4 kings, I need to select any 2 of them, right? So it's 4c2 divided by total number of possible outcomes. So what are the total number of possible outcomes here? There are 52 cards and I have to select 2 of them. So the total number of ways, possible number of ways to select 2 cards out of 52 cards is again nothing but 52c2, right? Is there any doubt in this? Because it's actually very simple, but yeah, I mean, it does assume that you know a little bit of combinatorics. Okay, if that is clear, then okay, yeah, it's actually simple. So okay, so it's 4c2 by 52c2. What is this? So this is a little bit of calculation, maybe 4 into 3 by 2 by 52 into 51 by 2, and 2 gets cancelled. This becomes maybe 4 into 3. Okay, let me simplify it here only. I think 26. This should get divided by 4. 4 1s are 4, 1 4 3s are 12, 13 4s are 52. Okay, so this is 3 by 51. 3 should cancel 51 somehow. 17 to the 34 3s are 51. Okay, this is going to be 1 by 13 into 17. What is 17 into 13? 170 plus 170 plus 51, that is 30 20. This should be 1 by 221, right? So yeah, so this is the probability, the desired probability. Again, a simple question, just a counting problem, nothing very hi-fi. Okay. Maybe I will solve one more question on this same concept of pack of cards. A simple one again, not a tough one. So again, let's say you have a well shuffled pack of 52 cards. What is the probability that both of them are face cards? Probability that both of them are face cards. Now remember, I think ace is not counted in face cards, right? So just king, queen and jack. So again, you are going to pick 2 cards out of the 52 cards, right? The question now, instead of, so now earlier the question was what is the probability that both of them are kings. Now, well, the question is what is the probability that both of them are a face card. So now how many face cards are there? Again, let's just see. So again, there is, maybe I'll just write, so there is diamond, there is club, there is heart. I don't know what is spade. I have literally forgotten what spade looks like. Then each of them has a king, right? Each of them has a queen, and each of them has a jack, right? So these are all the face cards that are there in this 52 cards, right? How many of them are there total? This is basically 4 into 3, right? 3 into 4, 4 into whatever, 12 of them, right? So if I have to get a face card, it has to be from these 12 cards, right? So again, by the similar logic that we used here, we need to choose 2 cards from these 12 cards. What is the number of ways of doing that? So it's going to be 12c2 divided by total number of possible outcomes, which is going to be again 52, 2 cards from 52 cards, which is going to be 52c2, right? This will be again 12 into 11 by 52 into 51. If I remember, 4 3s are 12, 4 13 4s are 52. This 3 will cancel this by 17. This is 11 by 13 into 17, and we saw 13 into 17 is 221. So this is 11 by 221. right? Simple question again, very basic counting question, right? Okay, so now let us see some questions based on sets, right? Again, simple questions, but yeah, nonetheless worth doing. So let's say E. So yeah, any questions? Didn't see the chat, so okay, no questions. So let's say E and F are two events. Okay. So what is the probability that exactly one of E and F, exactly one of E and F occurs? What is this probability equal to? So if there are two events, either the two events can happen simultaneously, or they can happen individually, like only one of them occurs, or none of them can happen, right? So the best way to visualize this is perhaps through a Venn diagram. So let's say that, so this is this event E, this is this event F, okay, and there is, so the probability that we are being asked is exactly one of them has to occur. So what is the portion of this Venn diagram that contains exactly one of E and F? I hope you will agree that it's this shaded part that I am shading, right? This part is basically the region where both E and F are occurring, but that is not desired for us right now, right? So we can just do this, right? So we have to basically find the probability of this shaded region in some sense. So what is that equal to? So if you remember, so this is also called as something called symmetric difference, right? E delta F. We are basically being asked what is the probability of the symmetric difference. So it's simple. If you remember, either you can just look at the Venn diagram and directly write what it is, right? So let's say, so okay, here is this so how do I write it? So we can write this as E, so the set E is equal to what? E minus F plus E symmetric difference with F, right? This is clear, right? So E minus F is this, just this, okay, maybe I'll use this curve. So E minus F is just this much, okay, and E delta F is this much. If I add both of them, I get the entire E, right? So I have just written that thing, okay. Now now both of them are disjoint, right? So this portion that is E minus F, and this thing which is, sorry, okay, maybe I should, this is E intersection F, right? Sorry. So this is E intersection F. I am really sorry. Actually, I don't know if I need to do all this thing. I can just write it. So E minus F plus E intersection F, right? This is correct. Okay, fine. Let us see what happens. So now, since these two things are disjoint, this thing and this thing are disjoint, if I take the probability measure of it, so P of E is, this is going to be what? If both of them are disjoint, the probability just gets add up, right? Because they are disjoint events. You can just, if I'm taking the probability measure on disjoint events, those will just become the sum of the probabilities, right? So it will be probability of E minus F exclusion f, or whatever you want to call it, plus p of E intersection f, right? Now okay, this is there. I need to somehow come with E delta f, right? How do I come with that? Okay, E delta f can be written as follows. E delta f is what? E delta f is basically E union f minus E union f minus E intersection f, right? Is this correct? E union f minus E intersection f, right? This is correct. That means that E delta f union E intersection f is equal to E union f, right? So what we are saying is that the symmetric difference that we just saw, which is this thing plus this thing, this area, this set plus this intersection, if I club both of them, I will get the union, which is the entire E union f, right? So if that is the case, and both of them are again, now this time both of them are disjoint, right? Because this thing which is inside is like disjoint from whatever whatever it is here and whatever it is here, right? So now I can use the same trick. I can basically say that probability of E union f is equal to probability of E delta f plus probability of E intersection f. That implies probability of E delta f is equal to probability of E union f minus probability of E intersection f. Now what is probability of E union f in terms of individual probabilities of E and f? If you remember, by inclusion exclusion, right, you can write this to be probability of E plus probability of f minus probability of E intersection f minus probability of E intersection f. This becomes probability of E plus probability of f minus 2 times probability of E intersection f. This is f, this is E. Sorry, my handwriting got a bit messy. Yeah, sorry for like I think I took a little bit more time than I should have, but yeah, let me know if this is not clear, okay? Sort of, yeah, it's clear. Can you tell me which steps exactly? From here? Okay, so what I am trying to say is, so let maybe use different colors here. Okay, so this is your E, this is your F. Okay, this is your E, this is your F. I am saying what is E delta F, what is the symmetric difference? The symmetric difference is just this much, right? This thing that I am coloring in green. Is this fine? Any doubts here? Okay, now what is E intersection F? E intersection F is this point, right? This portion, right, which is common in both E and F. This is clear, right? If I take union of both of them, right, if I take the union of both of them, what will I get? I will get this entire region, right, which is this thing, right? Is that correct? Now what is that entire region? That entire region is nothing but it's the union of E and F, right? It's the whole thing. So whole thing, right? This is exactly what is written. This is exactly what is written here. So this is E delta F, which is this portion. This is E delta F is this portion, right? The green thing that I colored. E intersection F is this thing that is common in both of them. and I'm saying that if I take union of these two, I will get E union F, that thing that is there in red, right? So it is exactly what I said in just in set notation, right? Now another observation is that whatever there is in this green color, right, whatever that we marked here in green color, this thing is actually disjoint from this thing that is there in common in both E and F. Is that also fine? So if two sets or if two events are disjoint, the probability of their union is just the sum of their probability. Is that does that seem reasonable to you? Okay, maybe internet is not there. Yeah. So I have just written that since these two events, this and this, are disjoint, the probability, if I take probability of this entire thing, I can just write it as probability of their individual, so sum of their individual probabilities. This is what I have written here. And E union F was there here already, so that is already the probability of E union F, right? Now if that is the case, from here I can, so remember what we were asked of this probability exactly, right? E delta F. If now E delta F, I have got an expression for P of E delta F from here, right? I can just take this thing to on the LHS, right? It will be probability of E union F, which is already here, right, minus this probability, which is E intersection F. Is this fine? Okay. Now what is probability of E union F? So are you aware of inclusion exclusion, this thing that I have written? Right. So I have just applied inclusion exclusion. So probability of E union F is probability of E plus probability of F minus probability of E intersection F. This entire thing is this thing, right? And there was already a minus probability of E intersection F, which I have written here, and hence there are two probability of E intersection F. I just club them, so it will become 2 times probability of E intersection F, and probability of E plus probability of F was already there, so it's just written like that. Is this okay? Okay. Thanks for asking. Okay. Okay, there is another question which is similar to this thing. Which question number was this? 6th, 7th. Okay. There is an 8th question. The question is, there are two events Q and R. Okay. Probability of Q is equal to 1 by 3. Probability of R is equal to 2 by 3. Okay. There are two events Q and R. Probability of each of them is given to be 1 by 3 and 2 by 3. And it is given that probability of their simultaneous occurrence. Whenever you listen to words like simultaneous, what it means is that probability of Q intersection R, right? Both of them are happening. That is given to be 2 by 9. Okay. We are asked what is the probability that either Q or R occurs. Probability of either Q or R. That is equal to this set Q union R, right? Again, just make the Venn diagram. This is Q, this is R. You have been given probability of each of them individually, right? So if the Q, this is just the set Q, that is given to you, right? The probability of that set is given to be 1 by 3. Then there is this another set R, which is again this thing. The probability of that set is given to be 2 by 3. Then there is a intersection here. The intersection is, maybe just show it in red color here. Whatever you see in red is this thing. That thing is shown to that thing is given to you by 2 by 9. Then what are we being asked? What is the probability that either Q or R occurs? So either Q or R can occur if it is the probability of this entire thing, right? because in this entire thing either Q or R is occurring. Outside this neither Q nor R is occurring, right? So we are being asked what is the probability of Q union R, right? So now you can simply use your inclusion exclusion again here, right? Q union R is equal to probability of Q plus should not write P, should just write P, okay? T of Q plus probability of R minus probability of Q intersection R. And each of these terms are known to us. This is 1 by 3 plus 2 by 3 minus 2 by 9, which is equal to 1 minus 2 by 9, which is equal to 7 by 9, right? Simple question. Any doubts here? So it's just I think the catch in the question is to understand the words and write it in terms of the sets. Whenever you have words like simultaneous or something like that, it is basically referring to the intersection of the events, and if there is the words something like either of the things or at least one of these things are happening, it's basically referring to the union of the sets. Is that fine? Okay, so what else? I think I will take one last question maybe. Okay, I will take just one last question, and after that, if you don't have any questions, we can end it. Okay, just 9th question. Okay. So okay, R is basically the set of real numbers. Okay, we are given 4 options and we are asked which of these are correct. Okay, the first option is as follows. It is given En is equal to 0, 1 by n. These are open intervals such that n is equal to 1, 2 and so on. This is a ring, is the question. Is this a ring? That is the first question. There is another question. Okay, again just let's say En, the same definition, 0, 1 by n is equal to 1, 2 so on. This is a sigma algebra. This is the C. This is again En defined in the same way, 0, 1 by n is equal to 1, 2. This thing is not a monotone class. This is not a monotone class. There is another D is equal to Fn, which is denoted by, now this is closed interval 0, 1 by n is equal to 1, 2 so on, is a monotone class. So you have 4 options. We are asked which of these is correct. Okay, so let us see what is En. So basically, so this is your real line. Okay, let us say this is your 0, this is your maybe, so I hope you can see that if this is 1, these sets are going to be 0. So what is En? So En, so let's say that's M, that E, okay, maybe I should write it this way. So what is E1? E1 is open interval 0, 1 by 1, which is 0, 1, right? What is going to be E2? E2 is going to be open interval 0, 1 by 2. Similarly, E3 is going to be 0, 1 by 3. So the left interval, so the left side is always it starts from 0, open interval 0, and goes till 1 half, 1/3, and so on. So if this is 1, this is 1 by half, right? This is 1 by 3, this is 1 by 4, and so on, right? So it's the first set is basically your this set, right, starting from here, closing here. The second set, E2, is again starting from here but ending at half. Third set is again starting from here, ending at 1/3, and so on, right? So this is what E1, E2, E3 is. So this is what these sets are, right? These collections are. And Fn here is nothing but the same thing but with a closed interval, that's all, right? So now, well, is En a ring? Well, a ring is closed under union and symmetric differences, right? So let's see. So let's say you have E1, right? Let's say what is E1 delta E2, which is equal to 0 comma 1. This is E1, symmetric difference. Oh, sorry. Oh no, I have to say look at the difference, not the symmetric difference, right? So it's 0 comma 1 minus sorry. So what is E1 minus E2? This is equal to 0 comma 1 minus 0 comma half, right? So this is your 0 comma 1, this is your 0 comma half. If I remove this part, this much, from 0 comma 1, what I will be left with is this thing, right? That just, I hope that is clear. So this will be equal to what? Closed half comma 1, right? Now this doesn't belong to any En for all n, right? Because Ens don't have this kind of form. Ens always start from 0 and end at some fraction, okay? None of the Ens will start from 1 by half. So none of the Ens will start from 1/2, right? So since this is E1 minus E2 doesn't belong to any of the Ens, this means that this is not a ring, right? Because rings are closed under differences. This is not true. Okay, just a simple argument, right? Now let us check if Ens are a monotone class. Are they a monotone class? Okay, are they a sigma algebra? This is a good question. So is this are EIs a sigma algebra? That, do you think it is a sigma algebra? Well, sigma algebras are closed under countable union, right? This was the first thing. Let us look at the second thing. So Ens, for if Ens are sigma algebra, then the countable intersection of Ens should also belong to the sigma algebra, right? So what is the countable union of, so let us look at this countable union, right? N equal to 1 to infinity En, which is basically intersection n equal to 1 to infinity 0 comma 1 by n, right? So you see, so it's like you are starting from this set, you are intersecting it with this set, it becomes this set. Now you intersect it with this set, it becomes a smaller set. Again intersect with this, come here, and this sequence is, since going here, it will eventually reach to 0, it will reach close to 0, but it will never touch 0, right? So this thing will actually be phi. It will be a null set, because intersection of the countable intersection of these sets is actually empty, but phi doesn't belong to your doesn't belong to any En for all n, right? I mean, this collection doesn't contain phi, right? So but phi should be a part of your sigma algebra, as we discussed earlier, right? So for this reason, this is not going to be a sigma algebra as well. This is not a sigma algebra as well. Now, since phi doesn't belong to this collection of Ens, it is also not a monotone class, right? It is not a monotone class. So it is not a monotone class is actually a correct statement, right? Because phi should belong to a monotone class. But phi is not there in this class set, in this class of sets. Since it is not there, it means that it's not a monotone class, and hence this statement is true. Okay, and maybe this D option I will just leave it as an exercise, like just check that this fn's, these are actually not a monotone class. This statement is actually wrong. I'll just leave it as exercise. You can just check it out. I mean, just see maybe an exercise for you. Okay, so I don't know, did you have any is there any question I can explain? Otherwise this is all I had. Yeah, go on. First question was nothing. So it was a simple question. So you have two words, probability and statistics. Okay, a person is randomly choosing letters from these two words. Okay, what is the probability that the two letters that you choose from these two words are the same? I think this is also there in this week's assignment, but yeah, anyway, I just discussed it. So the only possible common words, letters that one can pick is A, I, or T. And I mean, it's a simple thing. It is nothing big. It's just see what is the probability of A coming from here, what is the probability of A coming from here, and just multiply those two probabilities. It will be 1 by 1 over 10. Do the same thing for I and T, sum them up, it will be 8 over 1 by 10, which is equal to 4 by 55, right? Nothing big, right? Any more questions? Okay, if not then we can stop. Okay, these lectures will be uploaded. The links will be shared accordingly, right? Okay, so if there are no other questions, then think I can just stop the broadcast. Yeah, okay, fine. Thank you for joining. See you next time. Bye.